Okay, let's dive into this. Welcome back to The Explainer. So you just finished looking at these 6 broad classes of nutrients, right? That gives us an awesome foundation for figuring out what our bodies actually need to keep running. But knowing what we need is really only half the battle. Now we're going to look at nutrient sourcing, basically how the body actually goes out and gets what it needs.
To wrap our heads around this, I want you to picture the human body as this incredibly advanced manufacturing plant. It's constantly working, constantly producing, and repairing itself 24/7. But obviously, a factory can't run on thin air. It needs raw materials. So we've got to ask the big question. How does our physiological factory actually acquire these nutrients? Does it just build everything completely from scratch, or does it have to rely on outside deliveries? Well, the answer is this really fascinating mix of both, and that is exactly what we're breaking down today.
Here's our roadmap. We're going to cover 4 main areas. First, essential nutrients. Second, deficiency diseases. Third, non-essential nutrients. And finally, conditionally essential nutrients. Let's jump right in.
Section 1. Essential nutrients. These are what we call the must imports, the vital materials our body's factory absolutely cannot make on its own.
So the crucial point here is the definition. An essential nutrient must be supplied by the food we eat. Why? Because the body either doesn't synthesize it at all, or it just can't make enough of it to meet our daily needs. Without a steady delivery of these specific materials arriving through our diet, the whole factory basically grinds to a halt.
Let's look at some real-world examples. Now, the absolute most essential nutrient on this list, the one your factory needs above literally everything else, is water. We've also got vitamins, which have to be imported via our meals. Then there are the essential amino acids. Those are the building blocks of proteins that we simply can't manufacture from scratch. And finally, the essential fatty acids, specifically omega-3 and omega-6. All of these have to be packed onto the trucks of our daily diet and shipped directly into our system.
Moving on to Section 2, Deficiency Diseases. Basically what happens to our factory when that supply chain breaks down and it completely stops receiving these essential imports.
Well, when the supply chain fails, we see the onset of a deficiency disease. This is a health condition that develops when the body just does not get enough of a specific essential nutrient. That shortage leads directly to impaired physiological functions, and those show up as characteristic signs and symptoms. In fact, in the world of nutrition, a substance is only officially considered an essential nutrient if its absence strictly causes one of these deficiency diseases. That's the actual biological criteria. And this brilliantly illustrates that direct cause and effect relationship. Look at how these missing nutrients map right onto specific diseases. If the body isn't getting enough vitamin C, it leads to scurvy. Not enough iodine in the diet, that leads to hypothyroidism. And if there's a shortage of iron, the factory develops anemia. So these aren't just random illnesses, they are the direct, observable result of a missing dietary shipment.
But hey, here's the incredible silver lining. Because these conditions are caused by a supply chain breakdown, the fix is literally in the supply chain. When the missing essential nutrient is finally added back into the diet, those abnormal physiological changes are actually corrected. Reintroducing the nutrient effectively reverses the damage and gets your factory humming along perfectly once again. Pretty amazing, right?
All right, Section 3, Non-Essential Nutrients. This is where we get to look at the incredibly cool in-house manufacturing capabilities of the human body.
So, a non-essential nutrient is defined as a substance that can be synthesized by the body from other materials we get from food. Now, please don't let the name fool you here. Non-essential absolutely does not mean unimportant. These nutrients are vital for your survival. The term just means it's not essential that you import them directly from your diet in their final form, because your body is actually smart enough to build them itself from spare parts. Let's draw a super clear distinction for your notes. Essential nutrients must be supplied directly by food. Non-essential nutrients, on the other hand, can be synthesized by the body. One is an import, and the other is an in-house product. So what exactly is our factory successfully producing all on its own? Well, examples of non-essential nutrients include cholesterol, and yes, despite its bad reputation in the food world, your body naturally makes it. We also have some non-essential amino acids like alanine and glutamine. There's certain fatty acids like palmitic acid that we can synthesize, and maybe the most impressive one, glucose. Your body can actually make its own glucose from other compounds through a process called gluconeogenesis. You literally don't have to eat glucose for your body to have glucose.
Which brings us to Section 4, Conditionally Essential Nutrients. You can think of these as emergency shipments. Now, what's really fascinating about this is the dynamic nature of biology. A conditionally essential nutrient is normally non-essential, meaning usually your body synthesizes it just fine. but it suddenly becomes essential under specific circumstances or physiological conditions. The rules literally change because the body's internal environment has changed.
Let's look at two great examples to make sense of this. First up is vitamin D. Normally, your body synthesizes vitamin D on its own when your skin is exposed to sunlight. But if you're in a situation where you just aren't getting enough sun, it suddenly becomes conditionally essential. You have to get it from your diet. Another great example is choline. Under normal circumstances, your body makes some choline. But during specific physiological conditions, like periods of rapid growth, pregnancy, or even when you're fighting off a nasty illness, the factory's demand completely skyrockets. The body just can't make enough to meet those sudden high needs, meaning you absolutely must import it through your food.
So, we've looked at all the building blocks, the essential imports, the in-house non-essential products, and those emergency conditionally essential shipments. But that leaves us with one massive, provocative question to end on. How does the body actually extract energy from all these imported and manufactured materials? We know where the factory gets its physical parts, but what about its power? Keep that question rolling around in your head because it perfectly tees up your next lesson, where you're going to be defining exactly what a calorie is and calculating the actual energy content of the food we eat. Catch you in the next explainer.